Dear students, in the last class I talked about how to represent transfer functions in MATLAB software. In today's video, I will show you how to find poles and zeros from a transfer function using MATLAB software. Okay, so to find zeros, poles and gain of a transfer function, you have to remember one command, that is TF to ZV. Its meaning is transfer function to zero pole. Or you can also find transfer function by using zeros and pole. For that case, you have to remember the command that ZP to TF. Okay, so first of all, we are talking about transfer function to zeros and pole. So the syntax for using the command is, so here you can see z comma p comma k equal to transfer function to zero pole in bracket numerator polynomial coefficient and denominator polynomial coefficients. So just you have to remember this one, the TF to ZV. So here Z represents the zeros of the transfer function, P represents the pole of the transfer function, and K represents the gain of the system. So consider one transfer function. So this is general representation of the transfer function. Okay, so in MATLAB, the transfer function can be represented using the following syntax. So first of all, we have to represent the coefficient of the numerator polynomial. So here we denoted as n. Then we have to represent the coefficient of the denominator polynomial. Here we represented d. And then you have to present this command, that is the zpk equal to tf to zp in bracket n comma d. Then you can easily find the zeros and poles of the transfer function. Similarly, from the pole, zeros and gain of the system, the coefficient of the polynomial of a transfer function can be obtained by using this command, that is zp to tf, just opposite. So first one is the tf to zp and this one is the zp to tf, and the syntax will be this one, just reverse. So n and d will be the left hand side and the right hand side will be the zpk. Let's take one example. So this is the transfer function, that is the s plus 2 divided by s cube plus 10s square plus 15s plus 150. So first of all, we have to represent the numerator coefficient, then denominator coefficient, then you have to apply this command and you can easily find the zeros, pole and the gains. Okay, so let's go to the MATLAB and try to implement the previous example, that is the s plus 2 divided by s cube plus 10s square plus 15s plus 150. So first of all, we have to represent the numerator coefficient. So s plus 2 means its coefficient is 1 and 2. Next, we have to represent the denominator coefficient. So the denominator polynomials is s cube, means its coefficient 1, then 10s square coefficient is 10, then 15s means its coefficient is 15, and 150 means its coefficient is 150. Then you have to write the command. So we have to find zeros, pole and gain. So z, p and k. And then, so first of all, here we are transforming zero transfer function to pole 0. So tf to zp. Then write the numerator and denominator. Okay. So run this program. So here you can see. So the pole is at minus 2. Sorry, 0 is the minus 2 and pole will be the minus 10 and plus 3.8730i and minus 3.8730i, and the gain is 1. This is a very simple example. Okay, next we try to find the numerator and denominator by using the 0 pole and k, means it will be the reverse. So let's take any of the z. So here we consider z as the -2 and consider pole. We are taking 0 at 0 location, then consider the -1, then consider that pole is available at -4, and you already know the gain. So here we consider gain is 10. Okay, now try to find the numerator and denominator of the transfer function. So just n and d, then just change, it will be the zp to tf, and it will be z comma p comma k. That's it. Just run this program. So here you can see this is the numerator of the transfer function, sorry, numerator coefficient, the 10, 20, and this is the denominator coefficient of the transfer function. Now if you want to print in the transfer function proper, means s cube, s square, so you have to remember this command, that print sys in bracket n comma d comma s. Okay, now run the program. So here you can see, so num divided by 10, it is 10s plus 20. Here you can see this is the coefficients, and s cube plus 5s square plus 4s. Okay, now we are taking one more example, that is the s cube plus 2s square plus 5s plus 6 divided by 3s to the power 4 plus 4s square plus 8s square plus 9s plus 10. Okay, so just write the numerator coefficient. So it will be very easy, just remember these things. Just you have to remember present the numerator portion, that is the 1, 2, 5 and 6. Then you have to represent the denominator coefficient, so it will be the 3, 4, 8, 9 and 10. Then just use the formula, that is that z p k equal to, so we have to find transfer function to 0 pole in bracket n comma d. That's it. Just run this program. So here you can see the zeros, location of the zeros, location of the pole, and the value of gain, that is the 0.333. Okay, so it is very simple. So you have to just remember the command, that transfer function to 0 pole or 0 pole to transfer function. So in the next video we see how we can plot pole and zeros of a transfer function in MATLAB. Okay.